All right, we're going to determine whether we can prove triangles congruent by side, 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 or side, angle, side. Let's look at number 1. Here we have one congruent side, we have an angle, and a second side. So here we have side, angle, side, side, angle, side, congruent. And let's write a congruency statement for the triangle. So y is our congruent, 1, q, which leaves t, which be congruent to k over 1 c p. Let's look at number 2. All right, we got a side. We have a second side. We have no angles that are shown congruent, but they do share a side, and by the reflexive property, AC is congruent to AC, so we have side, side, side. And we have AD is congruent to CB, so triangle ADC is congruent to triangle CBA. Make sure you're going in the same direction with your congruent sides and our angles. Number 3, we have two congruent sides. We have a congruent angle. So we need MK to be congruent to MK. That's our reflexive property. So we have side, angle, side. And how would we label this? Well, triangle, we know that this angle and this angle are congruent. So we can start here and go this way along our congruent side. So we have MJK is congruent to triangle KLM. Let's look at another example. Here we have side, side, two sides. We have an angle. So we have side, angle, side. But wait, side, side, that would be this angle. So these are not congruent because the angle needs to be between the sides. Here's a previous example we have. It's the same thing. We got two sides. They share the third side. So EF is congruent to EF. Side, side, side. And triangle, which way do you want to go? If you want to start at C, C and D are going to match. So CEF, if we go that way, triangle CEF is congruent to triangle D, E, F. All right, so here we got two sides that are congruent, and so we either need an angle or we need the other side. Well, right here, those little arrows tell us that we have parallel lines. And parallel lines cut by a transversal are going to produce angles. In this case, it's alternate interior angles. So that's a side, angle, side, side, angle, side. And let's start with our here along the one. So we have triangle DJA is congruent to triangle E along the one, MA. All right, making good progress. Here we have a side, second side, a side, a second side, and an angle. But so side, angle, side, but the angle is not between the sides, not congruent. All right, let's look at our last example here. We got two sides. And here we have our x, which makes these angles the same because we have our vertical angles. So that would be side, angle, side. And then got to write our congruency statement. So how about ABC? What's congruent to ABC? Well, A is on the 2 on this side here, so E, and we would go that way, excuse me. So we go E, D, C, triangle, and we should look like that. Now let's practice some proofs. Everybody loves proofs. So given, we always start with what we're given because we have to start at the beginning. AB is parallel to CD. All right, so let's get our givens in there. And then notice that AB is parallel to CD. So angle ABD here is going to be congruent to angle CDE because they're corresponding angles, as you all remember from when we did our angles and parallel lines. For D is the midpoint of BE. So that was a given. So BD is congruent to ED, and that's the definition of the midpoint. So we have, let's get rid, this angle is congruent to this angle. This side is congruent to this side here. We were already given that AB is congruent to CD, so we know that this is true. And so triangle ABD is congruent to triangle CDE by SAS. So let's do another. Given KM is congruent to MN, given KM and NM, right there, let's mark them so we don't lose our place. LK is congruent to LN. LK and LN. So LM is congruent to LM. That is our reflexive property. Something is congruent to itself. So we're going to have by side, LKM is congruent to triangle LNM, side, side. And moving on. All right, let's put in our givens. AD is congruent to AB. AD is congruent to AB, conveniently marked for us. That is our given. AC bisects angle DAB. DAB is right there. So if it bisects it, that means these two are congruent. That is also our given. We know that DAC is congruent to CAB, because that's the definition of a bisector, of an angle bisector. AC is congruent to AC. It's a reflexive property again. So triangle ADC is congruent to triangle ABC by side, angle, side, and make sure your congruent parts match up. All right. JM is congruent to MN. That's given. L is the midpoint of JN, also given. So JM and MM are congruent. JL is congruent to NL, definition of a midpoint, because it means literally cut in half. So these two will be congruent. And I think you can see where we're going here. LM is congruent to LM because of the reflexive property. And triangle JLM is congruent to triangle NLM because of side, side, side. And we are